Bismillahirrahmanirrahim. Assalamu alaikum viewers, and welcome to the third part of our partial fraction decomposition. And those who have watched my first two videos related to the same topic, they are now well acquainted about the first two methods of partial fraction decomposition that we have discussed, along with couple of examples related to that. So now today in this video, which is the part 3, we are going to discuss the third type of partial fraction decomposition, which is this one. In the previous two videos, we discussed type 1 with the relative example. In the second video, we discussed type 2 with the relative example. Those who have watched, they are very much acquainted with that. Okay, so now what the third type says regarding this decomposition is that if you are dealing either proper or improper rational algebraic expression, if you are having a quadratic factor of this type in the denominator d of x, then in that case you are going to decompose that denominator in the algebraic sum of partial fraction of this type. Okay, and here b and c, capital B and capital C over here, are any real numbers, and in the relative example of type 3, we are going to understand how to evaluate the values of these constants. All right, so let's move ahead, and before moving ahead to the example, let me just try to put down a certain figure how such kind of proper fraction or improper fraction looks like if it is having a denominator of this type. For example, I say, hang on, my pen is not working. Like for instance, if I'm having a rational function of a type like this. Okay, now you can see here that the degree of the numerator polynomial and the degree of the denominator polynomial are equal, both are 2. So in that case, you have to first of all divide these two polynomials first of all, and you have to express in the form of the summation of the quotient and the proper fraction so formed with respect to the denominator and its divisor. So first of all, let us decompose this thing with respect to the division. So once both degrees are same, so I have just divided these two polynomials in this form. You can see here, and this division is just a primary level algebraic division. People are well aware with it, and I have discussed the thing several times in the previous videos, so there is no need to repeat the whole process here. So I've just done this thing, and you can see here that this is my quotient, this is my remainder, and this is my divisor. So this proper this function, this improper function can be expressed like this. This is the quotient, the summation of the quotient and the proper fraction so formed by this remainder and this divisor. So it is actually this. Okay, now you can see here that this is now a proper fraction, and in the denominator you're having a quadratic expression. Now you're going to break up in this form. You're going to decompose this proper fraction in the form of this partial fraction. Okay, so this stuff is equal to this, and I'm going to break up this proper fraction. You can use any variable you want at the constant, x squared plus 1, and then after that you are going to do the work. And if, for example, if you are having a function which is proper in nature, this is a proper fraction in the beginning, you can see, So there's no need to divide the stuff. You're directly going to express it in the partial fractions like this. Okay, so now let's move ahead and see the example, how we are going to evaluate the values of these two constants. All right, let's see it. Okay, so here you go, an example related to the type 3. And over here in this example, I have merged your type 1 and type 3 over here. So you will enjoy this example, I'm sure. So you can see here that in the numerator, the degree of the polynomial is 5, and the denominator polynomial degree is 4. So numerator, degree of your numerator is greater than the degree of your denominator. This is your 5 and this is your 4. So now you are going to divide this stuff, all right? You have to express it as the summation of your a summation of your quotient and the the proper fraction so formed by means of your remainder and divisor. Okay, so let us divide this thing over here at this side. This is my dividend, this is my divisor. I'm going to divide it. Minus x, and I'm going to cancel them by changing the signs. And the remainder degree, you can see that it is less than the degree of the divisor, so I'm going to stop over here. This is my quotient, this is my remainder, this is my divisor. So this improper rational function is expressed as the summation of my quotient and the proper fraction formed by means of the remainder and the divisor. Alright, so this is it. Now you can see here, this is a proper rational function. I'm going to decompose the denominator with respect to the partial fraction form. But before doing that, let me simplify this expression, which is of the degree 4. You can see here that this x power 4 can be expressed as here in this form, and 1 can be written as 1 square. So now I can apply the formula of my a square minus b square. This is an algebraic identity which is equals to this, and this is something that you study in your pre-algebra courses like that. So this thing can be written as your a minus b and a plus b. Okay, over here this is my a and this is my b, so that's how I've written that. Now over here you can further see that if I write my 1 as 1 square, there's no harm in it. Now again I can apply this identity rule over here, so it can be further factorized, x a minus b and a plus b, because this time my a is x and my b is 1. And this is a quadratic expression that cannot be further factorized. It is irreducible now, so I'm going to copy it as it is. Okay, so you can see here that your x power 4 minus 1 expression is factorized in this in these three factors. Two of them are linear in nature, one is the quadratic. So I'm going to now decompose this proper fraction in the algebraic sum of my partial fractions. These two are of type 1, this is of my type 3. So I can write now this thing as a upon x minus 1 plus b upon x plus 1. That's how we have studied in our type 1 in the first video of this topic. And this is your type 3, and this is irreducible quadratic form. So I'm going to express it as cx plus d upon x squared plus 1. That's it. This is it. I just name it as my equation number 1 for convenience. Alright, so this improper rational function is simplified in this form. Now our next objective is to obtain the value of these four constants, a, b, c, d, the capital one. Okay, you can see here that the first two factors are linear in nature, so the two constant values can be obtained easily by equating these two linear factors to 0 and get the two values of x. Substitute them one by one, you're going to get the two constant values, and the remaining, these two constant values are going to be obtained by comparing coefficient process. Okay, so let's do it now. So you see that this stuff, this portion is equal to this thing. So I'm going to write it like this, that x upon x power 4 minus 1 is equal to the algebraic sum of partial fractions like this. And I recommend those who haven't watched the first two videos related to the same topic, they should watch them so that they can easily follow this video. Now what I have to do now, I'm going to take the LCM at the right hand side. I'm going to see the denominators. You can see that all the three denominators are entirely different from each other, so they are all uncommon factors. So LCM is basically the product of uncommon and common factors. I'm not having any common factor here, so I'm simply going to multiply all the uncommon factors, and that is going to give me my LCM. All right, so my LCM is nothing but the product of all uncommon factors here. And you can see that the multiplication of all these three factors is giving me nothing but x power 4 minus 1. So in the next step, I'm going to write this thing at x power 4 minus 1 instead of writing all these three factors for my convenience, all right? So you see, now what I'm going to write here, here, and here. For that purpose, in order to write the value at the first place, I'm going to multiply my first fraction with the entire LCM. Okay, so for that purpose, I think I should use my pencil, so it is not going to mess up. Okay, so I'm going to write my entire LCM in the numerator of my first fraction. Okay, you can see here that this factor and this factor gets cancelled. So at this place, I'm going to write the product of my a with these two factors. Okay, you can see that now. I hope it's visible, these two factors. Okay, so let me write it down here. All right, so and now in order to write at the stuff at the second position, I'm going to multiply my LCM with the second fraction. Okay, just like what I did over here. So I'm going to multiply my second fraction with my LCM. You can see here, and this x plus 1 is going to cancel this x plus 1. What is left are these two factors multiplied by b. Okay, and this is something that I'm going to write over here. So b into x minus 1 into x squared plus 1. All right, so this is it. Now at the third position, I'm going to multiply my third fraction with my LCM, and this one is going to cancel out this one. And what is left is the product of cx plus d with x minus 1 and x plus 1, which is actually x squared minus 1. So I can write x minus 1 and x plus 1 as x squared minus 1 as well. Okay, so this is it. You can see here that in the first two terms of the numerator, I'm having two linear factors. Okay, so the values of my two of my constant values can be obtained by substituting the value of x, which I'm going to obtain by equating these two linear factors to 0. Okay, so before doing that, I'm going to cancel out the denominators, because you see that the product of these three factors is nothing but x power 4 minus 1. So this is actually equal to x power 4 minus 1. So I'm going to cancel out this thing equals to this. What is going to left here is x equals to this whole stuff. Okay, so alright, and I name it as my equation number 2. This is it. Now, in order to obtain the values of my x, these are my two linear factors. You can see over here, these are two my linear factors. I'm going to equate them one by one to 0. So let me do over here at the left side. Okay, x minus 1 equals to 0. This thing gives me x equals to 1. And x plus 1 equated to 0. This thing is giving me x equals to minus 1. So these are the two values of x. I'm going to substitute these two values of x one by one in my equation number 2, and let's see which constant value I'm going to get now. Okay, so let's do it. Okay, so now let us substitute now x equals to 1 here. So wherever I'm having my x, I'm going to put 1 over there. Okay, so I've just put down this statement here, that comparing coefficients of your x cubed, x squared, and x, and constants at both sides we get. So this coefficient on comparison equal to 0, because I'm not having x cubed here, that's why it is 0. I'm not having x squared over here as well, so this coefficient is also equal to 0. This is also 0. That's my equation 2. This coefficient, you can see here, that a plus b minus c, the coefficient of x over here is equal to 1, because you can see the coefficient of x at the left hand side is 1. So this thing is, excuse me, a plus b minus c is equal to 1. This is my equation number 3. And finally, the constant at the right side is also equal to 0, because I'm not having constant at the left side. So this thing is equal to 0. My fourth equation is a minus b minus d equals to 0. This is my fourth equation. Now, two constant values are in my hands, a and b, which are and both of them are 1 upon 4. So with that respect, I can easily obtain my value of c and my value of d easily. I can pick up any equation I want and I can get the two answers. Okay, so let me pick up my equation number 1. I'm going to substitute the value of my a, the value of my b, and this thing is going to give me my c value. So you can see here that it is on taking the LCM. Okay. Okay, so it is 2 by 4 plus c. So on simplification is 1 upon 2 plus c. So this thing gives me that my c is equals to minus 1 upon 2. That's it. Now in the same way, I can pick up this equation 2 and equation number 4, whatever I want, because they're involving d here. So these two equations can give me the value of my d, the last constant. So let me pick up my equation 2. I can also pick my 4. It's my choice. Okay, so it is 1 upon 4 minus 1 upon 4 plus d equals to 0. So this and this gets cancelled. This thing gives me that my d is 0 here. Okay, so this is also now done. All the 4 constants are now at your service. A and B are 1 by 4, C is negative 1 by 2, D is your 0. Okay, so now when you pick up this equation number 1, which is equivalent to your function, equivalent to your improper rational function. So now it is done. So let us do it. So equation number 1, your x power 5 upon x power 4 minus 1, this is equal to x plus 1 upon 4 into x minus 1 plus 1 upon 4 into x plus 1 minus 1 upon 2x upon x squared plus 2. So I can write it like this as well. D is 0 upon x squared plus 1. Now I'm going to give a final touch to this, to my right hand side. This is copied as it is. Okay, and this was something like this. So plus minus give me minus x upon 2 times x squared plus 1. So you can see now that's how we perform the partial decomposition of such denominators which are having irreducible quadratic expression with them. So that's all for today's video. I hope you have understood. So if you find this video helpful and you feel that the third type of partial fraction decomposition is very much clear to you and you can handle problems related to that, so please subscribe my channel, hit on the like, and share it with your other friends and learners so that they can also hail themselves, and try to exercise the relative problems as much as you can to strengthen your grip in this type of solving such kind of typical functions, all right, involving single variable. So that's all for today, and inshallah soon I'm going to upload the final video involving the fourth type of our partial fraction decomposition in the near future. Take good care of yourself. Allah Hafiz.